Good morning or afternoon or evening, whenever you are watching this. This next set of videos is about verifying trig identities. All right, that's our new lesson here. We're in, for us, it's lesson 5. If you're just watching this, just generally, this is the video where and we're not working with any of the really like hairy, scary trig identities yet. We're still working with kind of just the basic Pythagorean ones and then our normal trig functions. But what we're doing is we're showing in this video how we can actually have an equation set up and how can we take that equation and how can we make one side equal the other. All right. And so the thing that's a little tricky about this is there's not like you have to do this first, you have to do this next, and there's a little bit of judgment and a little bit of experimentation that has to go into this and up front, and that scares a lot of students. And I get it, but I guess what I want to do is encourage you to just go for it and see what happens, and treat this like anything else. Like if you're walking, say, somewhere unfamiliar, you don't know where you're going, and you go down the wrong path. You're like, okay, well, I guess I'm going to turn around and go back to where I know where I am, and then take a different path, right? And so that's kind of the approach you have to take with this. So let's get into this. All right. So we're going to just basically work over about 4 examples on verifying trig identities, and then get into our practice. So before we get started on that, I just want to talk about what are the identities that we are using to verify these larger ones. What's in our toolbox? So we have our whole sine, cosine, tangent, right? And sine, I'm not going to write sine and cosine down just because I always try to encourage everybody to write things in terms of sines and cosines, because I think that that's a much more direct route. So I usually start with writing out cosecant and secant. And that's because those are like the 2 obvious ones that we have to write in terms of sine and cosine. So your cosecant is 1 over sine. Your secant, right, is, I should probably use theta. It's better. All right, 1 over cosine theta, right? And then we have our, tangent theta and cotangent theta. So tangent theta is sine theta over cosine of theta, and then cotangent theta is the reciprocal of that. I always want to say the inverse. It's not the inverse. It's the reciprocal of that. Multiplicative inverse, but not the true inverse. All right. So cosine theta, sine theta. And these are, like I said, these are reciprocals of each other. If you have tangent and cotangent next to each other, they will always make 1. Just like cosecant will always make 1 with sine, and secant will always make 1 with cosine when you are in a multiplication style problem. All right. And then the other set of identities that we're going to be using pretty extensively here are the Pythagorean ones. So that's the starting one, right? Our initial launch point is this cosine squared plus sine squared equals 1, right? And think of it as, a squared plus b squared equals c squared, where c is 1. Okay, so from that we get, if you solve for sine squared, right? So you move cosine squared over, right? You would go, so let's see that over here. So if we have cosine squared theta plus sine squared theta equals 1. If we solve for sine squared, you would subtract cosine squared from both sides, right? And then that's going to give you sine squared theta is equal to 1 minus cosine squared theta. So we're going to put that one down here. So this gives you something that's just solved for sine squared. And then similarly, and I'm not going to write it down because I think you can kind of intuit it, because if we did the same thing and we solved for cosine squared, you're going to get the exact same equation, except that cosine and sines trade spots, right? 1 minus sine squared. So we got those 2, and then we have the others. So we have 2 others. We have 1 plus tangent squared equals, and it's always like, all right, which one is it? Is it secant or cosecant? Well, look down here. If this is cosine, it always lines up with the other one that has cosine in the denominator, and that's secant. So it's secant squared. And then, therefore, cotangent squared must pair up with cosecant squared, and indeed it does. All right, so these are the formulas, the trig identities that we are going to use when we're verifying it, and just a quick little tiny review on these. And in the next video, we're gonna start using these, and look forward to seeing what happens. All right, thanks.